All right, here's a look at number 8, and we're just going to go through several problems and have a look at how to find, well, critical values, intervals of increase and decrease, and we're going to be accompanied by a few of my youngest of the 4. That's Graham, you hear in the background, and I'm sure you'll hear Ethan here pretty soon. Sometimes you need the derivative too, but y prime, 3x squared minus 12. There you go, there's your derivative. If you need that for your problem, great. The next thing is, hey, we need critical values. And remember, there's 2 different places that we look for critical values. One is by when setting y prime equal to 0. So our 3x squared minus 12, our derivative, we actually set it equal to 0 to see where we have horizontal tangents, where it goes flat, where we have like a peak or a valley possibly, or sometimes we have something called an inflection point. But we're interested in, that's a critical place. It's an interesting place. So I'll finish solving this, add 12 to both sides. Divide by 3, and what happens when you square root that thing is you get x is plus or minus 2. Those are 2 critical values, plus or minus 2. The next is anywhere that y prime is undefined, and the only time that's going to happen is if we have a denominator, and we have no denominator, so that's not even an issue. Now, final question is intervals of increase and decrease. So you are welcome to peek at a graph. So you're looking at this. I happen to know that this is a parabola, and I have some information about, it looks like it has maybe a couple of critical values at plus or minus 2. If I had to guess, and I'm not even going to look at a graph, it looks like at negative 2 we got some kind of peak or valley. At positive 2 we have a peak or valley. I know the end behavior of this graph looks something like this, so I'm just going to go peak, valley, gone, and I think that's my graph. When it asks for the intervals of increase, so let's do increase right here, I and C. It's asking for from what x to what x. Is it going uphill? And it looks like on the left-hand side until the peak, it's going uphill, so that's negative infinity until negative 2. And then it's also going uphill from the valley at 2 on up to, what is that? So we'll put a comma here, 2 to infinity. Those are the 2 places it's going uphill, the regions of uphill. And then the decrease region is right between the peak and the valley, from negative 2 to 2. And that should satisfy any of your problems for number 8.